Hey guys, I hope you had a good weekend. Today's assignment is like putting it all together. So we're going to put together the pieces from the first and the second graphing rationals assignment. Not going to tell you a whole bunch of new stuff, and then you're going to do your Desmos again. So, for example one, because we're going to go straight into examples. Like I said, not learning much new. We're just determining the key features of the graph of the given function. So here's our function we're working with. Now, important in pink here. Since I can't factor it at all, I just start. If I could factor this, that's the first thing I would do. So the key features we're finding are the horizontal asymptote, the vertical asymptote, the x-intercept, the y-intercepts, and if there's any holes. Okay? If I can't factor it, there's no holes. So I can even go there and say, oh, there's none, because there's nothing I can cancel top and bottom. Okay, but let's work through them piece by piece. Okay, so for the horizontal asymptote, okay, remember, that's where we compare the degree of the numerator to the degree of the denominator. Okay, since they are the same, the degree of x is just 1, the degree of this x is just 1, so that's when we take our leading coefficients, and it's y equals that. So I have y equals -4/3 for my horizontal asymptote. Okay, remember, for the vertical asymptote, we set the simplified denominator, which it already is, equal to 0, and then we just solve. So I write 3x plus 1 equals 0, I solve for x. I get -1/3. So that means my vertical asymptote is going to be at x equals -1/3 for this function. Okay, remember, putting together the pieces. For the x-intercept, we set the simplified numerator equal to 0, and we solve. So my numerator is already simplified, so I write -4x equals 0, which means that x equals 0, which means I have an x-intercept at 0, 0. Okay. Remember, putting the pieces together, anytime we want to find a y-intercept, no matter what kind of function, we just plug 0 in for x and evaluate. So I take my function, I have -4x, so -4 times 0, over 3x plus 1, so 3 times 0 plus 1. That gives me 0 over 1, or 0. So I have a y-intercept at 0, 0. And like we said, there are no holes. Okay? All right, another example. Determining the key features. Okay, this time our function is f of x equals the quantity -4x plus 16 over the quantity x squared minus 16. Remember, the first thing we're going to do is factor and simplify. In this case, I can actually do that. Okay, so I take my function, I pull out my GCF of -4, and I get x minus 4. Okay, then I factor, it's the sum or difference of squares, so I have x minus 4 times x plus 4, which means these two will cancel, and this time I will have a hole. Okay. When I work with my function from here on out to find the x-intercepts, y-intercepts, vertical asymptote, horizontal asymptote, I can work with the simplified function, okay? So when I go to do that, I say, okay, the degree of the numerator is less than the degree of the denominator, because -4 doesn't have an x, it's got a 0 for the degree, and this is a 1. Anytime the degree of the numerator is less than the degree of the denominator, we get a horizontal asymptote at y equals 0. Then, we set the simplified denominator equal to 0 to find the vertical asymptote. So if I have x plus 4 equals 0, I get x equals -4. I fill in my vertical asymptotes at -4. Now, to find the x-intercept, we set the simplified denominator equal, not denominator, I can't talk today, simplified numerator equal to 0. So I write -4, it's not equal to 0, I can't solve that, so there is no x-intercept. So I write none, or if you're doing it on Delta Math, click none. For the y-intercept, we plug in 0. I'm going to go ahead and plug it in the simplified function. So I'm going to have -4 over 0 plus 4, which gives me -1. That means my y-intercept, I plugged in 0, I got out -1. 0, -1. Now we have to find our hole, because we did have a hole, because we could factor and cross out a factor. So I know the hole is where I crossed it out. So x minus 4 is what I canceled. If I solve for the x, I get 4. So it's at an x value of 4. Then I plug that into my simplified equation. So I have -4 over x, which is 4, plus the 4. I'm going to simplify that down to -1/2. And I say, okay, my hole is at 4, -1/2. All right, last example of key features, and then we're going to talk about graphing. All right, so if this is our equation now, we have x squared minus x minus 6 over the quantity x minus 3. Okay, I'm going to do this just like before. Remember, the very first thing I do is I simplify. Okay, x squared minus x minus 6 factors into x minus 3 times the quantity x plus 2, which means there is a factor I can cancel. When I cancel that, it gets rid of the denominator completely. Okay, because it gets rid of the denominator completely, that means there's no degree over degree, so there is no horizontal asymptote. Okay, I can't compare top to bottom, there's no longer a bottom. So for horizontal asymptote, I would say none. The same applies for a vertical asymptote. There's nothing left in the denominator I can set equal to and solve, so I have no vertical asymptote. Okay, now, blah, blah. Okay, for for x-intercept, we're still going to set it equal to 0 and solve. Okay, x plus the numerator. I solve, I get negative 2 comma 0. Okay, then for the y, I'm still going to plug in 0. Doesn't matter the kind of function. And I plug in 0 and I get 0 plus 2. Okay, so my y-intercept is 0 comma 2. Then I solve. Oh, I made a mistake on my hole. No wonder it didn't work. Ooh, we should fix this right now. Let's fix this. Silly me. Okay, the hole should be at x minus 3 equals 0, which means that the hole is at 3. Okay, then we're going to plug that into our equation. So we're going to have 3 plus 2 equals, you can't see that, I should show you. Okay, so we have x minus 3 for our hole, which means we have a hole at 3. 3 plus 2 is 5. So when I go up and I write my hole, I'm going to have a hole at 3, comma 5. Okay, and it's going to be beautiful. All right, how does this apply to graphing? We're going to use key features to graph. This first one we're going to use is going to be delta math. So as long as you can put all the key features in, the delta math will actually create like the graphs for you. Okay, so let's look at this first one. If I have negative 4x plus 20 over the quantity x squared minus 25, once again, I start by factoring and simplifying. I'm going to fill in all my key features from my simplified form. So I have no degree over 1 degree. That means the degree of the top less than the degree of bottom gives me a horizontal asymptote at y equals 0. I set this equal to 0. I get x plus 5 equals 0, vertical asymptote at negative 5. I have no x-intercept because negative 4 can't be equal to 0 in the numerator. And then in the denominator, not denominator, but I plug in 0 and I get a y-intercept of negative 4/5. And then I solve for my hole, same way as before. Now, when we go to graph this, okay, I'm going to start by drawing in my asymptotes. So you'll see that there's a dashed line here at y equals 0. That's my horizontal asymptote. Okay, if you're doing this on delta math, you're just going to drag your line, click horizontal asymptote, drag it over to where it goes. Okay, same thing with a vertical asymptote. If you're doing it on delta math, you click vertical asymptote, drag it over to where it goes. Because there is no x-intercept, on delta math, you just want to click on it. Okay, there is none, you can't place it. Okay, on the y-intercept, I click y-intercept and I pull it up to approximately negative 4/5. You just need to get it close on delta math. Okay, go ahead and graph my hole. Okay, so it goes at 5, negative 2/5. I draw it as a little circle when I draw it by hand. Okay, on this then, you would just say plot. The delta math will plot it for you and you won't have to worry about the way it curves. We're going to talk about that more tomorrow. The graph is going to go through any intercept and will be on both sides of the hole. Remember, it gets closer and closer to my asymptotes, but it's not going to cross these asymptotes. Okay, so it goes curves in, curves in. If you can do the key factors, you can do this. Okay, last example of the day. Start by factoring every time. So I turned the numerator into x minus 3 times x plus 1 over negative 4, x minus 3. I noticed that this and this cancel, leaving me with this. Okay, this means that there's no horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. Okay, on delta math, that just means you wouldn't click it. Okay, vertical asymptotes, there are none. There's no variable in the denominator. There's no vertical asymptote. For the x-intercept, I can still set the numerator equal to 0 and solve. I get negative 1 comma 0. For the y-intercept, I still plug in 0. I get 1/4. Hole does exist because I simplified. I get 3, I plug in 3, I get 3 comma 1. So when I go to graph it, I say, oh, there's no asymptotes, not dashing any in. I can go ahead and place my x-intercept, -1, 0, place my y-intercept, 0 and 4th, draw my hole, and this is just going to be a linear function with a hole. Because if I think about this, this is really just 1/4 x plus 1/4, but there's a hole now, okay? All right, good luck.